All right, coming to the next question, which is in a cathode ray tube at low pressure, a fluorescent glow on zinc sulfide confirms, and options are A, light emission from gas, option B, wave nature of radiation, option C, stream of charged particle causing excitation, option D, thermal conduction through gas. So you can pause this video and also wait some time and try to identify which is the correct option. Okay, so I hope you have identified the correct option. In this case, the correct option is C. This one, which says the stream of charged particle causing excitation. Now let's discuss why this option is correct and why other options they are not correct. So starting from option A, light emission from gas. So as you have seen, and I've also discussed in my video, that cathode ray that is emerging from cathode is basically not coming from the gas itself, because that is coming from the electrode. That is why this option is incorrect. B, wave nature of radiation. So cathode rays, they are not EM waves. We need to know that. They're not EM waves, they are particles with mass and charge. They have mass and they have charge. So they are not electromagnetic waves, so this option is also not correct. The option D, which is thermal conduction through gases. There is nothing to do with temperature right over here in cathode ray. So that is not, and it's also not linked with gas, right? So this option is incorrect. So if you have better understanding of cathode ray, you should be able to immediately select the option C, which is the correct one, which is stream of charged particle causing excitation. So you will have stream of a charged particle that will cause excitation because you have zinc sulfide present in the cathode ray tube. All right, let's move on to the next one. Okay, moving to next question, which is which observation proves cathode ray carry mass? Option A, they move in a straight line. Option B, they produce fluorescence. Option C, they rotate a paddle wheel. Option D, they are deflected by electric fields. Okay, so take some time, maybe pause this video and try to select the correct option. The correct option in this case is option C. Now let's discuss why this option is correct and why other options they are incorrect. Starting from option A. They move in a straight line. This shows that they are not scattered easily, right? So when we say we have a cathode ray, they are moving in a straight line, that indicates that they are not scattered easily. That is the proof we are getting from this statement, that they are not able to get scattered, nothing is coming, or even if you put something in front of them, they are not deflected by those things. They move in a straight line. That is being proved by statement 1. So it is incorrect. Why? Because we want to prove whether cathode ray they carry mass or not. Second one, they produce fluorescence. Now again, the concept of fluorescence is indicating the energy transfer. So let me write it down. Energy transfer. Energy transfer. So it's not indicating whether they have mass or not, right? So fluorescence is transfer of the energy, not the transfer of the mass. And we'll come to the option C, which is correct, but let's move on to the option D. They are deflected by electric fields. Now that proves they got charge, not the mass. Okay, so if the question comes like this, which observation proves cathode ray carry charge? Probably this or maybe this could be the correct one, but in this case we are asking, or the examiner is asking, what observation proves cathode ray carry mass? Okay, so in this case the option C is correct, which is they rotate a paddle wheel. So that means if you put a paddle wheel in front of cathode ray, I'm just creating something imaginary, and cathode rays, they're going to strike to this wheel, and it's going to rotate. It's going to rotate because they have the mass that is required, and the rotation, the momentum can be calculated by P is equal to mv. And this can also be asked in the numerical format also, where you have given the mass, where you have given the velocity, and you have to calculate the momentum of that particular X-ray. So that is very, very important concept that we have covered in this one. All right, we have wonderful next question, which is cathode rays show identical properties regardless of the gas or the electrode material that is present in the cathode ray. This implies option A, they originate from the gas atoms. Option B, they depend on pressure. Option C, they are universal constituents of matter. Option D, they require specific metals. Take your time and try to select the correct option. You can pause the video also. All right, so I'm going to give you the correct option. In this case, the correct option is C. They are universal constituents of matter. Now let's discuss why other options are incorrect and why this option is correct. Starting from A, they originate from the gas atoms. Now, why this option is incorrect? Because cathode rays, those cathode rays, they are not originating from gas. Nothing to do with gas. You put any gas, any different kind of gas, you're going to have same kind of cathode rays coming from the cathode itself. So that option is incorrect. They depend on pressure. Although low pressure is required for discharge, but that is not going to affect the properties. Okay, so that you have to understand. Low pressure is essential, but that is not going to change the property of the let me write it down. Property of rays is not going to get changed. Next is D. So we are discussing why these options are incorrect. They require specific metals. Again, when it comes to generating cathode rays, you can use different metals. They are going to give you same kind of cathode rays. So they are not dependent on specific metals. So this option is also incorrect. Now coming on to the C option, which is they are universal constituent of matter, and this is the correct one. And let's discuss why this is the correct one. And the cathode ray experiments, when scientists performed that experiment, they found out that no matter, it doesn't matter which gas was present. So that means they are not dependent on gas inside the tube, and which metal also. It doesn't matter what metal you were using for cathode, what gas you were using. Low pressure was required, but it was not affecting the property. So we need to understand that. So that means very, very important conclusion we can draw from here, that cathode rays, they are made up of fundamental particles, right, that are present in every kind of metal, every kind of material. So that means they are universal. So that is why they are universal constituent of matter. They are coming from any metal that you can use. They are not coming from specific metal. So in that case, this option is correct. All right, coming to the next question. In the absence of electric and magnetic fields, the straight line motion of cathode ray indicates. Okay, so in this question that examiners they are asking, if there is absence of electric and magnetic field, the straight line motion of cathode ray, indicates. We have options. Option A, they are neutral. Option B, no forces act on them. Option C, they are electromagnetic waves. Option D, they originate from anode. Take your time, select the correct option, and pause the video maybe. All right, now I'm going to give you the correct option, which is, in this case, is B. All right, now let's discuss why this option is correct and why other options, they are incorrect. Now, option A, they are neutral. So this is wrong because cathode rays are negatively charged particles. They are negatively charged electrons. They are not neutral. So this option is incorrect. Option B, let's come to that later on. Option C, they are electromagnetic waves, right? So EM waves, they don't carry charge. You need to understand that EM waves, they don't have, no charges there. But cathode rays, they have charge. So they are charged particle with mass, right? But in case of EM wave, that is not the case. So this option is again incorrect. They originate from anode. A very, very easy option to say that is not correct because they are cathode rays. So we are again left with the option which is no forces act on them. This is the correct option, which is B in this case. All right, so the option B is correct. Why? Because according to Newton's first law of motion, which is law of inertia, a body, the body, if that body is in a motion, a body continues its state of rest or motion until, in a straight line, unless acted on by external forces. So if no force is being applied to this particular particle, it's going to go in a straight line. So the option B is correct. No forces act on them. So that is why they are running in a straight line. All right. So that was all about this question. Let's move on to the next one. Okay, now we have a numerical type question, and this is not an easy one. We need to do some calculations over here, and I also want you to, practice these kind of questions. They are very, very important. The question is, a beam accelerated by 300 volts enter a magnetic field. So we have potential given over here, enters magnetic field of 1.5 multiplies by 10 to the power minus 3t and curves in a circle of radius 5 centimeter. Calculate E upon M. In many exams you will be asked these kind of questions, and they will you need to understand what are the formulas that are being applied and how we calculate, and you also need to apply these values in that formula, and then we have to calculate things. So in this case, pause the video and see if you can calculate any point of time where you think, okay, after that, I can calculate and get the answer. That would be great. Okay, if you can calculate now, you just pause the video and try it out. But somewhere, I'll also tell you a formula if you can apply that, and if you can calculate the correct option, that is also good. Okay, so we'll have multiple points where I'm going to ask you to give the answers. All right, let's see what data is provided. So we have number one, which is voltage. Voltage in that case is 300 V. That has been given over here. Okay, next is magnetic field is also provided, which is 1.5 multiplied by 10 to the power minus 3t. Okay, and then third is R, radius is being provided, which is 5 centimeter. And if you convert this into meter, that will be 0.05 meters. All right, we have what is being given over here. Now the concept that is required, the formula that is required for this, you can also derive the formula, but I'm going to directly give you the formula for calculating charge to mass ratio directly. And if you can just remember that and apply all these values in that formula, you should be able to get the answers. Okay, so the formula in this case is E upon M is equals to 2V divided by B square R square. So this is the formula that you need to remember for calculating charge to mass ratio when you have been provided with these. So, please try it out. You have all the values, see what kind of answer you'll get. I'll also try to do it over here, but the video becomes too long, right? You can't wait so long. So let me quickly give you how we can apply these values. So, we are calculating E upon M. What we'll have next is equal to E upon M is equal to, so I'm applying 2 multiplied by 300 because that is the voltage over here. Next is we have the value of magnetic field, which is 1.5 multiplied by 10 to the power minus 3, and also its square multiplied by 0.05 and its square. Now, if you calculate this, solve this, and I want you to please solve this by yourselves, and the answer is going to be approximately around 1.6 into 10 to the power 11, if your calculations are correct. So now we're going to look at the options, and we have 1.6, 3 options are there, 1.6, and then 11 with the 11 one, that is correct. And we can also give the unit, which is charge upon mass. It's very easy, right? Charge kg minus 1. That is the unit of charge to mass ratio. All right, so this is how you're going to solve these kind of questions, and they are very, very important questions because they require you to understand the formula, they require you to understand the concept, they also require you to apply that concept and solve the equations, and then you are able to give the correct option. In this case, the correct option is B. All right, try some more questions like this and see if you're able to solve these concepts easily. All right, again, we have a very important question, which is the deflection of electron beam increases when, option A, voltage increases, option B, magnetic field increases, option C, mass of the particle increases, option D, radius increases. Now, think about the concepts that you have covered or studied in this particular topic and see if you can come up with the correct option. You can pause the video and then I'll give you the correct option, okay? So the correct option for this question is B, which is this: magnetic field increases. Magnetic field, which is B, increases. That will cause, deflection of the electron beam increases. Okay, let's understand this first. In a magnetic field, electron move in a circular path, right? When you apply magnetic field, electron move in a circular path, and the balance of the forces is provided by this equation. EVB is equal to mv square divided by r. This equation you need to remember when it comes to magnetic field and the motion of the electron, right? So if you simplify this, you will get r is equal to mv upon EB. So here R is inversely proportional to magnetic field. So that means deflection is inversely related to the radius. Small radius is equal to more deflection. And large radius is equal to less deflection. So in this question, you will see that deflection of the electron beam increases when the magnetic field is going to increase, because we have seen that radius is inversely proportional by this equation. We have seen that, right? So larger radius means less deflection, smaller radius means more deflection, and magnetic field is inversely proportional to that one. So that clarifies this, that we have magnetic field increase is going to increase in the deflection of the electron. Now let's identify why these other options, they are not correct. Starting with option A, which is voltage increases. So if the voltage is going to increase, that what is the impact on deflection, right? So we need to again find out equation for that. So if we solve that again, you will get V is equal to 2EV upon M. So voltage is basically related with the velocity. So when there is increase in voltage is going to cause increase in speed of the electron, right? So that is going to cause increase in the radius. So that is another point. The deflection is going to decrease because radius is inversely proportional to the deflection, right? Okay, so that is why the first option is incorrect. Now moving on to the C, mass of particle increases. Now when it comes to mass, larger mass, you will have less deflection already, so that is incorrect. Last one is radius increases. So by definition, we have seen that larger radius means the smaller deflection of the particle that is moving in the magnetic field, right? So this option is also incorrect. So you can understand how you are able to answer not just by guessing things, but taking the idea from these kind of important equations, and that is why these equations are really important when it comes to final examination evaluation, because questions are going to come like that. Okay. So I hope you were able to select the correct option and your strategy was also correct. If not, then practice these kind of questions more. They will help you in preparing for your exams. All right, let's move on to the next one. All right, again, an interesting question. If two beams with different velocities, they pass through the same magnetic field. So you have magnetic field which is same, and you're applying two beams that are passing through that particular magnetic field, and obviously magnetic field is going to apply the centripetal force, and they're going to move because of the influence of the magnetic field, and they're going to turn into a circle because centripetal force is going to get applied. Now let's see, the question is which one will have smaller radius? Okay. Because you will have circles, right, like this, and maybe another one is going to move in a smaller one. So they are asking if this is R1, R2 for electron 1, electron 2, which one you think is going to be going to have smaller radius like this? Okay, what are our options? The beam with a higher velocity, all right, beam with a lower velocity, beam with the equal velocity, D, depends on the charge sign, okay. All right, so try to select the correct option. Okay, I'll give you some time. You can pause the video. I hope you have selected the correct option. The correct option in this case is B, this one. The beam with a lower velocity will have smaller radius. Okay, so let's find it out. We have already, we know that that radius is related with magnetic field like this. Right, radius is inversely proportional to the magnetic field, but it is directly proportional to the velocity. So if we take this concept and see with the higher velocity, it is going to have a larger radius, right? That means less bending in this case. And if you have velocity lower, you are going to have that particular radius also lowers, that is more bending. So that means the particle moving with a lower velocity for any reason will have lower radius, right? So the option B in this case is correct. Why other options they are not correct? Let's understand that also. The option is higher velocity. So higher velocity will have larger radius, not smaller. So that option is incorrect. This is correct. Equal. So already, we have discussed that. This option is also not correct. Depends on charge sign. Charge affect deflection of bending, not radius magnitude. So that option is also not correct, because when there is charge, it's going to affect the direction of bending. So direction. So direction is affected, not the radius of or the magnitude of the radius, right? So this is also incorrect. So that is why we have correct option, which is lower velocity.